Welcome to Trig Identities tutorial video. We're going to start off with sharing the trig identities we will be using. First, we have the reciprocal identities involving cosecant, secant, and cotangent. Then we have the quotient identities, which we will be using today, involving tangent and cotangent. Then we have the Pythagorean identities, and these involve the squares of sine, cosine, secant, and cosecant. We will not be working with those today. And finally, we have a few extra helpful identities that we will be working with today. These are not often on the identity sheets, but can be extremely helpful. So it involves sine squared x, cosine squared x, tangent squared x, and cosecant squared x. We will work with those later. To start off, our first problem is going to be cosine x times tangent x equals sine x. So, trig identities use this proper form, so we must put left side and right side. We do it in the form of a T-chart, so a line goes straight down the middle, separating the two. This line, no terms can cross this line as it represents the equal sign. So the left side of our equation is going to go on the left side of the chart. So that is where cosine x times tangent x goes. And then on the right side is sine x. As you can see in our quotient identities, tan x equals sine x over cosine x. This is the one to use, as it is better to use sine and cosine in trig identities to keep things simple for us to work with. So that is a big tip, is to always use cosine and sine. So for tangent x, as said, we are going to turn that into sine x over cosine x and leave cosine x, the first term. We're just going to put that over 1. So you can see we have a cosine x on the top and a cosine x on the bottom. By normal multiplication rules of fractions, we can just cross those out because they cancel each other out. So we are left with sine x over 1, which equals sine x, of course. So now that we can see, this is our final answer for the left side, which matches the right side. To officially prove this in proper form, we must put left side equals right side, and a little square goes to the lower right of the S. And that is our first equation. Moving on to our second equation, we will use the equation cotangent x over tangent x is equal to 1 minus sine squared x over 1 minus cosine squared x. Now, the square is in front of the x because if it was behind the x, it can become confusing as to where the squared matches. So having it in front of the x means that we're multiplying this entire term to the second power. And it keeps it simplified so that it is not confused whether it is going to just the x or not. So now we know it's going to the entire term. So starting with proper form, we have the left side and right side and our dividing line down the middle. Our cotangent x over tan x is on the left, and 1 minus sine squared x over 1 minus cosine squared x is on the right. So from here, we're going to take our quotient identities, and we can see that tan x is equal to sin x over cosine x, and cotangent x is equal to cosine x over sine x. So that is exactly what we are going to do. Cotangent x is equal to cosine x over sine x, and then sine x over cosine x, which equals tan x, obviously. So when you get this, we are going to keep the top portion of this the same as cosine x over sine x, and we're going to multiply it by the reciprocal of the bottom one. So it's going to be cosine x over sine x. From here, we multiply the top terms and the bottom terms to get cosine squared x over sine squared x. We are going to leave that as our final answer and go and work with this. We can see through our helpful identities that 1 minus sine squared x is equal to cosine squared x, and vice versa for the top, 1 minus cosine squared x is equal to sine squared x. So we are going to plug these in as cosine squared x on the top and sine squared x on the bottom, which, as you can see, is the same. So to solidify our proof, we do left side equals right side with our square. Thank you.